Howdy, everybody. Welcome to this presentation of the DevSecOps Working Group. It's being presented out of ATARC. In general, this ATARC DevSecOps Working Group started in March 2020. Our goal is to help improve efforts within DevOps at an interagency level with an initial mission statement to create software patterns that can be leveraged by those getting started with DevSecOps CICD pipelines in a government space. In this presentation, we're going to step you through the patterns we created, and we're going to then show you a video of a use case, their implementation. We'll talk about our standards and best practices. For any tooling that we're using, we're targeting open standards and open source tools that deliver these standards so that they can be used by a government agency immediately if they feel like using them, if they feel like downloading. We identified the patterns for basic CI/CD pipeline to work. They're based on Jez Humble and Mark Farley's continuous delivery book and other industry best practices. These software patterns, they're not like the Bible or anything. They're just basic patterns to help others just coming to grips with a new process and technology. They're the words used by the Gang of Four from the 1990s in their development of software patterns. So now that I've talked a little bit about the working group and what a DevOps pattern is and our best practices, I'll flip it over to one of my partners on the team who will step through at a very high level these 10 CI/CD patterns.
Okay, thanks, John. So in essence, there's 10 stages to the 10 different patterns that any delivery pipeline typically follows, beginning with the pull of the source code. This is to ensure that whenever you're deploying applications or infrastructure, you want to make sure that all your changes, everything that defines those environments and those applications are stored in a source code repository. That way, you can be assured that there's no manual intervention when actually deploying the applications or building out the infrastructure, that the process is repeatable from environment to environment. Stage 2 is actually taking that source code that you just extracted in stage 1 and building it out, whether it's a Java application, Node.js, if you're building out infrastructure for Terraform, any type of environment like that. Once the build is complete, then some basic unit tests are run against that environment just to make sure that, against that code, just to make sure that it was built correctly. In stage 3, is analysis of the code of unit test coverage that is associated with your application or infrastructure. And the intent of that is to make sure that the development teams or DevOps teams have made sure that they have developed unit tests that exercise their features to make sure that they match the acceptance criteria. Typically, we measure that coverage. We would strive to at least 90% coverage for a brand new application. For older applications, we would have like a get well plan where over time they would build up that percentage to get to that 90% watermark. In stage 4 is a quality scan. Basically, this is using a tool for assessing code quality to make sure that you're following best practices and that there is no potential bad practice that would impose a vulnerability of some sort. In stage 5, we actually do a security scan. This could be dynamic scanning, static code analysis, just to make sure that there's no code practices that cause a vulnerability. And in the case of a dynamic scan is, say, for example, if you need to scan a container, a Docker container, that there's no known vulnerabilities or vulnerabilities encountered when we try to access or work against that container. Stage 6, for teams that are new or maybe not as mature in the environment, we would typically post those built artifacts that were built in stage 2 and passed the test in stages 3, 4, and 5. We would post those artifacts to a repository somewhere that would hold it for later use to deploy in other environments. Typically, as you mature, the need for actually posting this to a repository becomes less because relied more on your code repository and your unit test coverages are high enough that your confidence level that what's in your code repository is your single source of truth and it's battle tested. So over time, the needs for storing it in a repository go down. But in any case, this is for new teams. So in stage 7, once we're ready to deploy, typically on the same pipeline, but maybe later on down the road, we'll pull that same artifact out from that repository. Stage 8 would be deploying the artifact to the target environment. Once that artifact has been deployed, first thing we want to do is do a smoke test on it, which is basically kicking the tires to make sure that the application is available, is not throwing any exceptions of any type, and is ready to respond to requests. And finally, depending on the environment that you're running in, that you'll execute a series of regression tests to make sure that your features are that are planned for that are supposed to be inside that application are actually there and functioning properly. And typically, as you go higher in the environments like pre-prod and prod, these tests would be very limited and non-destructive because we wouldn't want it to alter test data. So those are basically the same 10-stage patterns that typically any modern day best practice CICD pipeline would follow. And I'm going to turn it back over to my partner, John.
Thanks, Bill. So again, those 10 stages, we're targeting this DevSecOps pipeline for not just application software code, and as Bill said, not just infrastructure, but virtually anything coming out of an IT shop. So we talked about the DevSecOps working group. We started in March 2020. Our goal was to create patterns. We've taken it a step further, where we've taken these patterns and actually implemented them in working software, a CICD pipeline that could be ready for your usage, not in production or anything, but just to start kicking the tires in and start learning how a DevSecOps pipeline works. So with that in mind, I'll turn it over to our friend Samir, he's the real brains behind this organization, and he'll put on a demo of the 10-stage pipeline. Take it away, Samir.